this forward a little bit. So now this takes us to what's called the sampling distribution of means. In this example that I'm about to describe to you, I want you to follow along with me. All right, so let's assume that we are researchers interested in taking samples of 200 people while studying social media usage by students, and that this sample of daily usage lies between 0 and 240 minutes. Okay? So when I'm telling you that I want you to assume yourself to be a researcher, what I'm trying to communicate is that in this scenario that I'm describing right now, I'm a researcher. Let's say I'm researcher Mike, right? And you're another researcher. And every other student in our class are all researchers. So we're all working on this much bigger project of wanting to study social media usage among students. Okay? That's our goal. I'm my own person. I know that sounds kind of odd to frame it that way, but it's gonna make sense. I'm one person that's conducting research. You're another person conducting research on the same topic, and then all your peers are also conducting research on the same topic. And our goal is that I am going to sample 200 people. So I, as researcher Mike, I'm gonna go out and find 200 students that I'm gonna ask about their daily social media usage. You are another researcher. Let me see if I can do some drawing up in here. So I'm gonna call myself Researcher Mike, RM, and I'm gonna go out and I'm gonna get a sample size of 200 people. I'm actually gonna refer to this as N1 because this is my sample and I'm number one. Now let's say you are researcher student number one, and you are going to go out, you're going to draw your own sample of 200 students. And then let's say, we've got about, I think 20 something students in this class. I can do this for each individual student. Research student number two is going to go out, get their own sample of 200 students. Okay? So I'm not telling you, it's not my individual score of daily usage of social media. This is me going out and collecting 200 individual pieces of information and coming back with my sample. You're coming back with your sample. Each student comes back with their own sample. Now let's say we pulled samples of 200 people 100 times. All right? So I'm going to write dot, 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 like ellipses. Research student number, I don't even know who that would need to be. Probably number 99 has just finished drawing. So everyone in between, but research student number 999 just finished drawing our collective 100th sample of 200 students. Okay? Each of these 100 samples has its own mean of daily usage, and we can create a frequency distribution of these sample means. Now, each of these 200s is representative of our n. We have not yet discussed the idea of having collected sample means or calculated sample means from each of our samples. But let's say we did that. And notice here I mentioned that it's between 0 and 240. So maybe with my sample of 200 students, I had an average usage of 200 minutes. Maybe research student number one found an average of 100 minutes. Maybe research student number two found an average of 150 minutes. And then everyone in between. And then research student number 99 had an average of 200. Maybe they also had an average of 200 minutes. Now, I want to emphasize here that this is the mean of sample 1. This here is the mean of sample 2. This is the mean of sample 3. And then all the way down, this is the mean of sample 100. All right? Just trying to emphasize that we are talking about sample means, not individual score means. Okay? All right. For every sample drawn, every sample that we draw, we can calculate a mean. And we just did that. I gave you the means here. The distribution of these means, so all of these means that we just determined, can be made into a distribution, which we would call the sampling distribution of means. Okay? We're talking about a distribution. One of those, when I say distribution, I'm talking about that curve, right? Just like we've been talking about the normal distribution. I'm talking about, being able to graph these into a chart where, into a graph where we're creating that line. We're seeing, all these scores as they well, let me not get too far ahead, but we're graphing all of these scores, right? We can graph all of them to create a sampling distribution of means. In this example, I just got to emphasize, each of us is not an individual score. Each of us represents a sample of scores, which is why it's called a sampling distribution of means and not just a distribution of mean. All right. So characteristics of a sampling distribution of means. The sampling distribution of means approximates a normal curve. Okay, so this is true of all sampling distributions of means, regardless of the shape of the distribution. As long as the sample size is reasonably large, and when we say reasonably large, we're talking about over 30 participants in our sample. This is known as the law of large numbers. Okay, so as long as each of us researchers have a sample of at least 30 people, then we are creating a sampling distribution of means that approximates a normal curve. The mean of a sampling distribution of means, so remember the mean falls right in the middle of our sampling distribution, and I kind of jokingly referred to as the mean of means, the final boss mean. It is equal to the true population mean, and this is called the expected value. We'll learn more about that later, but that is the name of the true population mean. The standard deviation that we have in a sampling distribution of means is smaller than the standard deviation of the population, which means that the sample mean is more stable than the scores that it's made of. We're not going to get too deep into the weeds on that right now, but just know that the standard deviation from this sampling distribution of means tends to be smaller than the population standard deviation. All right. The sampling distribution of means as a probability distribution. This image should look very familiar from the discussion on probability. The biggest difference that you hopefully should catch right off the bat is that in the probability, when we're discussing probability and talking about the normal distribution, these symbols look different, right? When we were first introduced to the probability distribution, we saw these scores, right? We saw, 1 standard deviation. Then we saw 2 standard deviations, 3 standard deviations. These are all above the mean. So we saw this in probability. But now we're being introduced to this symbol of 1 sigma over x bar. And I'm calling it out as it looks before I tell you what it is. Okay? So, in sampling distributions of means, the probability of a mean occurring decreases as we move farther away from the expected value. I called it the mean of means, but let's use the terminology here, the expected value. All this is emphasizing is the same point that we discussed when talking about probability. The further away we move from that central mean point, the further we go in this direction, or the further we go in that direction, the less likely one of those means will occur. Okay, we're just not talking about individual scores now. In terms of what do we remember about the standard deviation representing, it represents an average distance a single score is from the mean. But now we're not talking about single scores, we're talking about samples. So since we are now working with sample means instead of individual scores, we have to replace sigma as our standard deviation. And instead we are being introduced to this symbol down here, which is called the standard error of the means. And the standard error of the means represents the standard deviation in a sampling distribution of means. Okay? So it's almost like kind of overlaying some new information on what we've already covered. All right, so I'm gonna pause the video here, and then we'll get more into the standard error of the mean in the next video.